I'm Anil Kumar. We are exploring combination of functions, and in this video we are going to understand what is quotient of given functions. So we are given two functions, f of x equals to x minus 1 and g of x equals to minus x squared plus 1. We need to sketch q of x, which is f of x divided by g of x, and then we need to write domain and range for this quotient function, right? So let's begin by finding out what q of x is. So q of x is given to us as ratio of f of x and g of x. We can replace f of x with the given function x minus 1, and g of x is minus x squared plus 1, right? Minus x squared plus 1. To simplify this function, we can factor, so we get minus x minus 1 in the numerator and minus of x plus 1 times x minus 1 in the denominator. This could be simplified, right? So x minus 1 cancel out. So we get minus 1 over x plus 1, right? Now once you cancel the common factors, we know we have a whole at this position, correct? And one restriction because of this is that x cannot be equal to plus 1, right? So when you write like this, after cancellation, you should definitely write x is not equal to 1. Now it is an equivalent function as given before. Now that is the function given to us. We'll now sketch this function. So to sketch the function, what we can do is we can have some critical values. So the first value is, of course, the vertical asymptote, which will be at minus 1, right? So let me make one scale here. So this is, let's say, 1, 2, 3, 4 on the negative side, 1, 2, 3, 4 positive side, 1, 2, 3, 4, and let's say 1, 2, 3, 4. Okay, now we have already found. Okay, let's begin with the vertical asymptote. So to sketch, we will write the vertical asymptote is at which point? At x equals to minus 1, right? X equals to minus 1. So minus 1, we have a vertical asymptote. Let me sketch this here. Okay, now this is 1. Now if I take x as 0, then I get the value as minus 1. So let me plot some points. So what we can do here is we can make a table of values just to get some values here. It'll be better. So let us write x values and qx values. So good points to check is always starting with the vertical asymptote. That helps, right? So if I write x equals to minus 1, I say it is a vertical asymptote. That is what we have already drawn. Now let's take a point which is 1 unit to the right of this, so which is 0. So if I substitute 0 here, then what is q of 0? Q of 0 will be minus 1, right? So at 0 we have minus 1. If I substitute plus 1, move one more unit to the right, in that case it will be minus half, right? So that is minus half, kind of here. As we move further, we know it's kind of approaching 0, right? So we have this graph which is approaching like this. On the other hand, if I am moving towards minus 1, then I know that if I take a value which is minus half, in that case, let me introduce minus half here, minus 0.5. Okay, that is minus half. So that will be giving me a value of 2. So my graph will approach negative infinity as I am approaching minus 1 from the right side. Now on the other hand, if I have minus 1.5, minus 1.5 is minus 3 over 2, right? So if I add minus 1.5 here, then in that case it is going to give me a plus 2 value. So I'll get a plus 2 value here, right? And if I have a value which is minus 2, this is plus 2. If I do minus 2 here, so minus 2 will give me minus 1 plus 1, right? So minus 1 divided by minus 2 plus 1 will give me plus 1, right? So we'll have a value at minus 2, it will be kind of here. So we'll have a graph which is kind of like this. Is it okay? So basically it is a reciprocal function which is shifted one unit to left. Okay, so that is how it is. Now that is the graph of our function, and we clearly know there's one more restriction, and one more restriction is when x is equals to 1, then what happens? When x equals to 1, we have a hole. So this point should have been a hole, right? So we'll block this. At 1, it is a hole. This is a hole here. So at 1, minus, so at 1 will be minus 2. So we'll have a hole here. So let me make a hole here. That is important. So this is the function. There is a hole here. So let me write down here hole. So that is the next restriction for us. So location of hole is 1 and minus half. Okay. Now this really represents the function q of x. So it has two restrictions for us. Now let us write down domain range for the function, right? Now as you can see, domain is all real numbers. We have domain as x belongs to real numbers, where x is not equal to, there are two restrictions, plus 1 and minus 1, right? Because this cannot be 0, plus and minus 1. As far as the range is concerned, y belongs to real number and y is not equal to 0, right? That is the value the function approaches, and it is not equal to minus half. So that is how we can get domain and range for this particular function. I hope it's absolutely clear to you how to find the quotient of two functions and write its domain and range, right? So be careful about the restrictions whenever you do this. Whenever you cancel out common factors, it results into a whole, and the denominator cannot be 0, which results to vertical asymptote. So that gives rise to your restriction. I hope that helps. Thank you and all the best.